Hey guys, welcome to another video. In this video, we're going to learn about one of the essential components in automobiles, a differential. Imagine a situation where you are driving a car in a straight path. At this time, all the wheels of the car will cover the same amount of distance. But when you want to take a turn, the inner wheels of the car have to cover a smaller distance, and at the same time, the outer wheels have to cover a longer distance. We all know that the speed is the distance traveled in unit time. So, for covering different distances at the same time, we need different speeds. The earlier automobiles had a single-wheel drive where only one wheel was used to drive the vehicle and all other wheels were left free to rotate at their independent axles. This allowed the wheels to rotate at different speeds and hence turning was not a problem. But this single-wheel drive acts off-center to the center of mass of the vehicle, making it dynamically unstable. So single-wheel drives are not preferred today. In case of two-wheel drive, that is, where two wheels are used to drive the vehicle, the driving wheels will be connected to a common shaft from the engine to transmit the motion. This will not allow the driving wheels to rotate at different speeds and creates a problem during turning. Meanwhile, the idle wheels can rotate independently. In order to make the driving wheels rotate at different speeds, a specific configuration of the gear system was introduced called the differential. The differential gear was first patented in the year 1827 by a watchmaker and was used in tower clocks. It wasn't till the end of the 19th century that differential gears were used in automobiles. A differential gear system is a gear arrangement that permits the transfer of power from the drive shaft to a pair of driving wheels and enables them to rotate at different speeds. A differential will be located halfway between the driving wheels connecting their axles. You might know that there are different types of drives like the front, rear, and four-wheel drives. The number of differentials used and their location in the vehicle differ for each type of drive. For a front-wheel drive, a differential will be enclosed within the housing of the gearbox. And for a four-wheel drive, there will be a differential between each set of driving wheels and a center differential between the front and rear wheels. The intended function of the differential is achieved by its arrangement of the gear. Let's have a look on a standard differential gear. Now you can see a differential gear with all its parts marked. There's a bevel ring gear, there are planet gears, sun gears, axles of the driving wheels, a pinion gear, and the driving shaft. Let us zoom in on the differential and discuss the parts one by one. A pinion gear on the drive shaft is used to transmit the power from the engine to the differential. A bevel ring gear is connected to the pinion gear. The bevel gear transmits power from the pinion gear to the rest of the system. A planet gear, which is also called spider gear in some terminologies, is connected with the bevel ring gear. This planet gear has two kinds of motion. It rotates along the ring gear and it also spins on its own axis. Two sun gears or side gears are allowed to mesh with the planet gear. These side gears are in turn connected to the axles of the driving wheels. An additional planet gear is added to the differential for sharing the work of driving the axles. When the vehicle travels in a straight line, the planet gear rotates along the ring gear but will not spin on its axis. Hence, there will not be any relative motion between the planet and sun gears. This in turn makes the sun and planet assembly rotate as a single unit. The peripheral velocity of the planet gear will be the same as the sun gears, making the wheels rotate at the same speed. But when the vehicle negotiates a turn, the planet gear, in addition to its rotation, spins on its axis. That is, when the vehicle is turned left, the right side wheel rotates at a higher speed than the left side wheel. The difference in the speeds of the sun gears makes the planet gear spin. The direction of spin of the planet gear will be opposite to the direction of the turn of the vehicle. When the planet gear spins, the sun gear, which rotates in the same direction of spin, has a peripheral velocity equal to the sum of rotational and spinning velocity of the planet gear, whereas the peripheral velocity at the other sun gear will be the difference between those two velocities. Thus, the increase in the speed of one wheel is compensated by the decrease in the speed of the other with the help of a differential. Other than transmitting power and making the wheels rotate at different speeds, the differential has other functions too. It helps in speed reduction and it also turns the direction of power flow by 90 degrees. That's the working of an open differential. But the open differential has its own disadvantage. It supplies an equal amount of torque to both the drive wheels. This can be a huge problem in a few conditions. A good example for this is when the wheels are in slippery conditions like being stuck in mud. When any one of the driving wheels slips or goes off-road, it spins faster than the other. At that time, the slipping wheel limits the torque because of less traction. When this limited torque gets applied to both the wheels, the vehicle cannot be moved much. In order to move the vehicle, more torque should be applied to the non-slipping wheel than the slipping wheel. This can be done either by making the two wheels rotate at the same speed or by limiting the difference between their speeds. Taking this into consideration, some additional features or modifications were made, which gave rise to the other types of differentials, like the locking differential and limited slip differential. Both these differentials function the same as the open differential during turns, but transmit more torque to one wheel when there is a slip. First, let's discuss about the locked differential. In addition to the components of open differential, a locked differential can have an electric, hydraulic, or pneumatic mechanism. This mechanism is used for locking the output pinions together. When locked, both the axles of the driving wheels act as a single shaft and rotate at the same speed. Thus, the torque transmitted is not determined by the differential, and hence, the non-slipping wheel acquires more torque. This locked differential is more preferred in off-road vehicles like Jeep Wranglers. Limited slip differential, or the LSD, allows both the wheels to rotate at different speeds, but it limits the speed difference between them. It uses several mechanisms for ensuring the normal differential action during turns and for transmitting more torque to one wheel during slips. Some of the basic types of LSD are clutch type LSD, viscous coupling LSD, Torsen LSD, and electronic LSD. In the clutch type, there is a spring pack and a set of clutch plates. The spring pack pushes the clutch plates against the side gears. When both the driving wheels rotate at the same speed, the clutches do not function. But when there is a slip, the clutches step in for making both the driving wheels rotate at the same speed. On slipping, the spinning wheel overpowers the clutch first, and this in turn makes the clutch pack assembly move as a single unit. Hence, more torque will be transmitted to the non-slipping wheel for moving the vehicle. In case of a four-wheel drive, when a set of drive wheels slips, the torque should be transmitted to the other. This can be done by using viscous coupling LSD. It consists of two sets placed inside a sealed housing, which is filled with a high viscous fluid like silicone-based oils. Each output shaft is connected with a set of plates. When the wheels rotate at the same speed, the plates along with the fluid also rotates at the same speed. But when the wheels spin faster due to slip, the plates attached to the slipping wheel also rotates faster. This in turn makes the fluid to catch up with the speed of the faster plate and drags the slower one along with it. Hence, the vehicle moves by transmitting more torque to the non-slipping wheel. This viscous coupling LSD is found in the Mazda MX-5 Miata. The next type of LSD is the Torsen differential. The name Torsen denotes torque sensing, and this differential consists of an additional set of specially shaped gears which acts during slips. Whenever a wheel slips, there will be a torque difference between the driving wheels, which binds the special gears together for transmitting more torque to the non-slipping wheel. Here, the transmission of the torque will be based on a torque bias ratio, which depends on the gear design, and hence, no torque will be transmitted when one set of wheels loses its traction completely. This is a major disadvantage of the Torsen differential. The advantage of Torsen is that it works instantaneously when a wheel slips, and it has less wear when compared to the other types of LSD. This Torsen differential is being used in Audi Quattro, Audi S2, Audi 100, etc. The electronic LSD has the same arrangement of the open differential with an additional clutch. In eLSD, the clamping force on the clutch is determined by an electronic control unit. The electronic control unit uses various types of wheel sensors and a microcomputer for monitoring slips electronically. When a slip is detected, the eLSD applies more torque to the non-slipping wheel. Electronic LSD allows for better handling in high-speed curves and during lane changes. The Porsche 928 and Saab cross-wheel drive vehicles use this type of differential. This eLSD is mostly preferred in sports cars. With this, we have covered what is a differential and its types. Hope you all liked this video and wait for more interesting videos in the upcoming days. Until the next one, bye.